Good afternoon. Welcome to the library's first RDM seminar. And what is RDM? It stands for Research Data Management. My name is Payne. I'm the moderator. Today's seminar includes 2 sharing sessions. Oh, what's the? Okay, have the agenda here, right? Include 2 sharing sessions, and then a presentation and a demonstration. And before we start the seminar, I would like to remind you to fill out the feedback form, which is on the chair, because your comments are very important to us. So, RDM, Research Data Management. Why does it matter? It matters because research data is the foundation of your research findings. That's why managing the data is an important step in research process. Effective data management will help you prevent data loss by having secure storage and also regular backup. It also makes it easier for you to turn the data sets into research outputs, just like journal articles, which are shareable, reusable, and citable. And when a data set gets cited and reused, which means it has a measurable research impact. Good data management also helps you meet the expectation of funding agency and journal publications. And we will come back to this in a later presentation. Today we are very privileged to have Professor Qiang Yang and Professor Cameron Campbell to conduct 2 sharing sessions for us. Our first speaker is Professor Campbell. I'm going to do a brief introduction. Is that it? Yeah, Professor Campbell is a professor in the Division of Social Science, Associate Dean for Research in HKUST. He received his PhD degree in Sociology and Demography from University of Pennsylvania in 1995. In the same year, he began his academic career at Caltech. 2013, he joined UST. Professor Campbell's research interests focus on population, family, stratification, and inequality in Chinese society. He has already published 4 books and many journal articles and book chapters. Professor Campbell is participating in the Lee Campbell Research Group, and he is very willing to share data with others. 2 dataset series have been made available through the Inter-University Consortium for Political and Social Research, also known as ICPSR, which is very well known in social sciences. Not only that, these datasets also come with very detailed description and user guide, which I think are excellent examples of best practices in data management and sharing. Now, Professor Campbell is going to tell us his experience in releasing research data. Please welcome Professor Campbell. Yes.
Great. So I'd like to thank the library for giving me this opportunity to come here today and share some of our experiences with you. I'm going to start by talking a little bit about, to try to persuade you that you really should be thinking, even now as a RPG student, thinking ahead to the need to consider data sharing and data release. A lot of my detailed comments will probably be more relevant for SHSS and SBM students that are working with data on human beings. But actually, of course, we have colleagues now in also in engineering in many cases that are working with data on people as well. I'll come back to that. But hopefully some of these comments that I will make will also be of more general interest. I'll briefly talk about sort of 3 projects, data collection projects, that my collaborators and I have been involved with, 2 of which have already resulted in the public release of data, the 3rd of which will eventually lead to the public release of data. We have other data collection projects ongoing. I don't have time to talk about them, and some of them we haven't really formed our plans yet. Veronica back there is working on some of our Republican-era educational data that we're collecting. But I'll talk about the projects to give you some sense of where I'm coming from. And then I'll share sort of what we've learned from all of this. You know, where does this notion that we should share our data come from? It emerged in the physical and life sciences, I think sometime in the 70s or 80s, as people with sort of particle accelerators and astronomers with telescopes began collecting massive amounts of data, and a norm emerged that they should make that data available to others. Also in genetics, people working with some of the genome data, there's been a expectation that a lot of that basic data is shared as well. And what eventually emerged is certainly in North America, Europe, and I think increasingly in most of Asia, except possibly, I think Japan's actually a little bit behind on this. But there's a norm now that funding agencies really demand that you make your data available and have a plan for releasing your data upon the completion of your research project. Journals increasingly expect data and code to be made available in an online appendix or elsewhere. So I think the old days, certainly if you worked in the social sciences 20 years ago, it was a bit like alchemy back in the 17th century, where everyone sort of had secret ways of doing their research that they didn't actually share with people, and they didn't share their data. We were supposed to just believe them, take it on faith that their data was good and that their analysis was correct. But we have moved into an era where at some level, if you are sitting on data and releasing to share it, increasingly it's viewed with some suspicion, much like you might view with some suspicion some inventor that came to you that said they had a perpetual motion machine but couldn't really explain the details to you and wanted to keep it secret. So we are moving in an era where the norm is transparency and openness. But there's some practical reasons for sharing your data beyond the fact that you may be forced to share it. One is that if you care about your citations, sharing your data when you're done with it especially may help with your citation counts. Hopefully, if you take care in your approach to releasing your data, people will cite your data, cite your documentation, and cite the papers that you wrote with it. And you may find that people, depending on what sort of data you're working with, people may find uses for your data that you never anticipated. And there's all sorts of things that can happen. There's increasingly people are trying to aggregate data that maybe I have a data set from China, somebody else constructs a similar data set from Korea, somebody has some data set from the Netherlands, that somebody out there may aggregate these to produce a comparative study. And also, again, releasing your data and your code will increase trust in your results. So this is just one example from, if you sort of care about citations, this is from one data set that we released. It's already been cited 16 times, and so if that's what you care about, that's pretty nice. Certainly we live in a world where certain administrators and so forth, not so much at HKUST, but there are some institutions out there that obsess over Google Scholar citations and want people to maximize. So I want to talk quickly about some of the data sets. I don't have time to really go into too much detail, but to give you some flavor of where our experience came from. The first is the China multi-generational panel data set, Liaoning. Actually, James Lee began collecting that in 1982. I became involved in 1987. He needed somebody to help manage the data, and I was familiar with DBase 3 Plus and DBase 4, which none of you have probably ever heard of, but at the time they were state-of-the-art for database management. And we grew the data set to about 1.5 million records with about 260,000 people, and we released it. And so this is remarkably complex data in the sense that it follows individuals over time. You can imagine having sort of snapshots of people every 3 years, actually over a 150-year period. We can also follow families. And so this is just the data, the raw data we were working from. These are from images in the Liaoning, these are the registers that we worked from, the household registers, HKUST, that we worked from were actually held in the Liaoning Provincial Archives. They were eventually microfilmed by at the time, the Utah Genealogical Society of Utah, now Family Search. And we hired actually coders over the space of 15 or 20 years who entered most of this data. Every column, as most of you can probably read this, but every column is one person, and there's basic information like name, age, and some annotations and so forth. And then this
here is a comparison of 1816 and 1819 to give some sense.
Oh, okay, I know what's going on.
Works.
Yeah, there's somehow some. How do I mute? Let me just. Mute. Okay. So here's just the material that was entered from those slides that we saw earlier. So we started out, and maybe this should be a lesson to you of how decisions that you make at the outset sort of can trap you later on. So we were working with, in the 1980s, it was very hard to work with Chinese characters in a computer, so we entered all of our names and so forth as pinyin. And then at some point in the 90s, we just decided it would be too difficult to go back and enter the names as Chinese characters. I don't have time to. But anyway, those of you from Liaoning, maybe may enjoy seeing. These are the villages covered. We have well over something like 500 villages in the data set. So this is a large undertaking. The point is that it's very complex data, and this will motivate some of my comments later. For those of you from Heilongjiang, we recently released another data set from a community from Shuangcheng. Is anyone here from Shuangcheng by any chance? Sometimes we actually get people. This was an unusual population that was covered by a state registration system in the 19th century. Essentially, in the late 18th century, the Qing government got tired of spending money on bannermen that were living in Beijing, sort of living off of state stipends, drinking their tea and fighting crickets. So they thought it would be a great idea to take them and send them to Heilongjiang to become farmers. This, of course, as you might guess, didn't really go over very well. But eventually the government did motivate, and they did actually, they used carrots rather than sticks. They did convince some people to move to Heilongjiang to become farmers, and then they set up a registration system to track them. And so we've entered, these are annual records, 1.3 million observations for about 100,000 people. And what's remarkable about the Shuangcheng data is we also have land registers, because the state essentially allocated land to these people and wanted to keep track of their land. So again, this was the raw data that we were working with. We had to hire people to transcribe all of this data. And then here's the land data. So we just started a new project. I'm not going to talk too much, but called the Jinshen Lu, which is essentially every 3 months during the Qing Dynasty, the state produced a personnel directory which listed about 15,000 officials, all the way from officials working in the Liu Bu, all the way down to sort of county level, low-level county officials. So imagine that, you had a major government sort of every 3 months producing a public, this was actually reproduced commercially, public list of all of its employees. I don't think we have such a thing today. And this is what the data looks like when we've coded it. So I don't have too much time to get into the details, but I tried to convince you that we spent a lot of time thinking about these issues in a lot of different contexts. And I have some thoughts to share with you. One is that if you are in a situation where at some level the data isn't just coming to you off of a detector on a on a particle collider or a telescope, if you actually have to enter data, I strongly urge you to use paid labor. I think a lot of people don't think about this at the outset, but we've always actually hired the people that are entering the data so that it's very clear that we own the data. We know people, people we work with in other contexts that thought, well, they could do data entry on the cheap by, say, having PG students do sort of farming out the data entry, having their PG students do a little data entry and a little analysis. This, or handing it out to collaborators, having them do some, one village to one person, they do a little analysis and so forth. This leads, every instance we've seen where people do this, it creates tremendous problems 5 or 10 years down the road, because people enter data on their own time and they're not being paid for it. They essentially, for very good reason, they tend to think of it as their own data. So, we know of projects in other countries actually where they followed this approach back in the 70s and 80s. 30 years later, they still are struggling with ownership issues, where people entered some data back in the 1970s and still don't want to sort of share it because they're still convinced that they've got one more paper they can write with the data. Another issue is when you're transcribing raw data, keep the transcription as faithful to the raw data as possible. Basically, if you've got data entry personnel working for you, don't ask them to make decisions. Basically, their main task should be to provide as accurate a transcription, warts and all, problems and all, of the original data. Leave the data cleaning for later, and do that as a separate stage where you have control over it, and then you can keep a sort of raw file and a clean work file. When you're building data sets, be wary of custom or proprietary data sets. We've seen other projects go terribly wrong with this. We've always actually been very careful to keep things using sort of open standards. We do our data entry in Excel. We do our analysis in sort of well-known statistical packages. All of our programs, we have thousands and thousands of lines of code, are all written in sort of fairly standard statistical packages. We've seen a lot of projects go very wrong because they, one typical example, if they say they use an outside vendor who says, well, we have this proprietary database system, and we'll make sure that the data is entered in this particular format, and this will be great. And then 3 years later, that vendor goes bankrupt and or gets sold to somebody else, and who comes back and says, well, we've got a new version of our proprietary product, and we're going to, for you to continue to access your own data, you're going to have to pay us a sort of sign a service contract with us, right? So make sure that whatever you're doing, you own the data in the sense, or that you can control the data, and that you're not putting yourself in a situation where you're dependent on a programmer, a vendor, or a student who could wander off one day and leave you sort of high and dry. If you share your data, make sure that you have, internally, say with co-authors, etc., students, make sure that you have very clear understandings about what they can do with the data. So generally, if you share data with people for the purpose of working on a paper together, you want to make sure, or you want to make clear whether or not they, in fact, they can continue to use the data on their own later. Normally, they shouldn't be able to, right? But I know of cases where people, say, shared data with a collaborator or a PG student with the initial understanding that it would be one co-authored paper, and then that person just wandered off and took the data and just continued to publish it or try to publish with it. That's a problem. Okay. When you're acquiring data, play by the rules. If you acquire data in an irregular fashion, for example, via personal connections, hacking, or whatever, it may be unpublishable. Over the years, I've talked to students who came to me with some great research idea, and I remember talking to this one student who wanted to study personnel or careers of officials in some place in China, and he was describing this data to me, and it sounded like something that I thought only the Zhujibu would have, right? It sounded very detailed. And I asked him, where did you get this data? And he said, oh, well, I actually hacked it. And I was like, oh boy, I don't want to, that's radioactive, right? I mean, for all sorts of reasons. There are other people talked about, they had a friend at some relative that worked at a bank and who could give them, data on firms and things like that. That may be fun, and you can write some interesting papers, but they're essentially, probably they're going to be unpublishable as soon as anyone finds out that you essentially got the data in that way. And then in the case of getting data from hacked Zhujibu servers, you may be opening up a whole world of problems that we may never see you again. So just secure, just play by the rules. Sometimes people want to take shortcuts when it comes to accessing data. Don't do it, because you could end up with 5 years of effort just useless. And I should be able to wrap up pretty quickly. Document everything. So as you're creating your data sets, you've got to assign names to fields or variables. This is fairly obvious. Preserve and document your code. I mean, I often have code that 6 months later, and I can't even figure out what I wrote. And when I started in 1987, when I sort of succeeded a programmer who had been doing all the data management in C, and I don't know if anyone even uses, I think a fair number of people still use C, but it was as if he had been trying to compete, in one of those competitions for, those competitions where you see how much you can do with one line of C code, with all these paren and double pluses and so forth. And so the code was just impenetrable. And I was experienced with C and C++ at the time, but it was hopeless, so I just wrote everything from scratch in DBase 3. And you can run into this situation if you hire a programmer that, especially if they use some obscure programming language and don't document it. I've seen this happen where the result is 5,000 lines of code that all have to be thrown out once the programmer leaves, because nobody can figure out what's going on, or fixing it is so hard that it's easier to start over. Document all the decisions you make during data cleaning and the preparation of a clean work file. Let's see. Now for venues for releasing your data, I suppose you could post something on your personal website, but that really is a short-term solution. As you're going to hear about later, many universities like HKUST have online repositories, and that should work well for data that is not sensitive, where you don't mind if anyone in the world can go there and download it. Especially if you're working with data that's potentially sensitive, where there may be a need for some kind of protocol for people to follow in order to gain access, maybe they have to sign an agreement, they have to have an institutional guarantor, then you may want to look at some of the discipline-specific repositories like ICPSR for social science. Now, I think that's pretty much it, I think. So I guess the final statement I would make is that just putting your data out there on the web in a repository doesn't necessarily mean that anyone is going to use it, especially if you have a complex data set. You'll probably have to spend a lot of time documenting it. Our moderator mentioned, this. We have probably all told produced 600 or 700 pages of documentation for the data sets that we've released. That includes slideshows, etc. And we've conducted workshops. This is all funded by the NIH, Shanghai Jiao Tong University, and other partners. And that's at some level, especially if your data set is complex, and even if it's well documented, you may need workshops for users that to have a chance to really ask questions and so forth. So this is one of our workshops back at Jiaoda in 2012. We had actually 4 summers in a row. I spent, these were 2-week workshops, and we had people actually that were international. This one was not, but we often had people from all over. So I think that's it for my remarks, and then I guess we still have a. Do we have time for any questions?
Sure, yes. Thank you, Professor Campbell. Very useful advice. Do you have any questions? Then I'll ask the first question.
Okay.
Okay. The papers I read about sharing data, almost all of them say researchers are not willing to share, and they don't have the habit to share. So seemingly you are doing something different. You're very willing to share. And what merits do you see in sharing data?
Well, for one thing, I mean, this is actually a big issue. There's a big controversies, especially in I think psychology and in medicine, where there are active vocal proponents of the view that people should not have to share the data. The New England Journal of Medicine even published an editorial calling people, I mean, this was the JM, calling people who asked for access to data, parasites, right? And so that's one extreme, but I think the norm, it almost goes discipline by discipline. So I think and even within subdisciplines, there's some variation. So I think, and there's regional variation as well, but I think the norm that's emerging in certainly quantitative social science and so forth, especially in North America, Europe, and actually in many parts of Asia, is that you should share, but you can find people that, I think one reason we share is we really think that well, for one thing, we're tired of the data. We've spent 20 years on it, and we think there's probably a lot more to be done with the data, but we would like to move on to other things. But it'd be nice if people use the data and cite us. But again, there's still people. I mean, it's not universal. There's still people that will come up with these arguments like, well, if I publish this data, people won't understand it and they'll make mistakes and things like that. And well, that's what the whole peer review process is about. I mean, I mean, that's part of science, right? People screw things up and it gets fixed and we move on. So you can find differences of opinion on this issue, but I tend to think of the people that want to keep their data, it's a bit like 17th century alchemists that don't want to share the secrets of their elixirs and so forth. There's something sort of a little dubious about it.
Thank you. Any questions?
Regarding
Please wait for the microphone because we are recording the event. Thank you.
regarding data sharing, I'm wondering is there any ethical issues involved, such as like participants' confidentiality?
Well, that's actually a very big issue. I didn't have time to talk about. So if you're, especially human beings, firms, so if you're from SBM and you get some firm level data, there's a whole set of procedures for working with potentially sensitive data. This is what I alluded to when I talked about ICPSR. It turns out that it is really hard to truly anonymize data. So we're working with historical data, everyone's dead, and at least North American practice, this actually varies by country, but North America and Europe, people who are dead are not accorded any expectation of privacy or confidentiality. That actually is not, actually if you go to parts of Asia, there's actually, you talk to researchers, there are some, it's a little more complicated. There's, people get worried about the release of, say, historical data on Barakamine populations in Japan. But yeah, it's a whole set of issues, and you have to really think carefully if you're sharing. You probably do not want to simply, if you've got data on live individuals, firms, things like that, then certainly there's protocols for, if you collect the data yourself, in theory, people should consent. And then if you're going to release the data, then it's probably going to be really hard to, as I think Netflix found out, it's just impossible to, or very hard to anonymize data. And so the typical solution is that if you have sensitive data, you house it at one of these specialized repositories. They can enforce agreements where, say, if somebody wants to access the data, they have to submit an application, they have to sign an agreement, and then their institution has to guarantee that they will, maybe that they will have a secure data facility, that they will follow all the protocols. So like in the United States, if you want to work with raw census data at a census secure enclave, you actually get sworn in as an employee of the census. And then that way, if you actually violate the terms of the agreements regarding confidentiality, you can actually be prosecuted for a felony because you've sort of violated an oath. So there's a whole rich set of protocols for dealing with that. It's almost like a whole sort of separate talk in its own right. But it's something you want to be aware of at the beginning.
Thank you, Professor Campbell. I think we can go to the next sharing session. Thank you, Professor Campbell. Our second speaker is Professor Chang Yang. Professor Yang is the new Bright Professor of Engineering, Chair Professor and Head of the Computer Science and Engineering Department. Professor Yang received his PhD degree in Computer Science in 1989, and he joined UST in 2001. Professor Yang's research interests include artificial intelligence and data mining. Our scholarly publication database shows that he has well over 500 publications. And he also wears many hats. He is the head of Huawei North Arc Lab, the recently established HKUST Big Data Institute, founding editor-in-chief of the ACM Transaction on Intelligent System and Technology, also the IEEE Transaction on Big Data. Professor Yang's contribution to AI and data mining is widely recognized. Just to name a few, he is the fellow of the Association for the Advancement of Artificial Intelligence and IEEE. In last month, he received the Distinguished Research Excellence Award from the School of Engineering. Coming up, Professor Yang is going to tell us something about one of his expertise, machine learning and AI. Please welcome Professor Yang.
You can just go to the first page. Yeah. So that's good. Okay. Okay. All right. It's a pleasure to be here, and it's an honor to speak after Cameron, good friend, and we are fellow colleagues in the data science committee. Cameron gave an excellent talk, very in-depth talk on data sharing. But here, Actually, my talk is about the history of AI and machine learning. So by going over this history, I hope to give you an impression on how important data is and some of the obstacles we met over this. So let me start. Okay, so we all know that AI is a big buzzword, artificial intelligence, and you have heard AlphaGo and many others. You probably have watched movies, a lot of science fiction movies recently. So people all over the world are excited by AI. Have you ever asked the question, why now? Why is AI suddenly hot now? Not yesterday, not 10 years ago, not 20 years ago, and now. And a big reason for this, I'm going to tell you, is about data. Okay? So without the data, there's no AI. And it's because the data is suddenly available in some areas, especially in the areas that we care about. Now, actually, some of the algorithms we are working on today, such as the ones used in AlphaGo, have been ready, have been sitting there for 20 years. Okay, it is the data that has not been ready. So this is the message I'm going to give to you. But to tell you this story, let me start from the beginning. In the very beginning, with Alan Turing's dream, you probably have watched this movie called Imitation Game, right? Let's see how many people watched it. Yeah, quite a few. Okay, so if you haven't, please watch it. The library has maybe have a copy.
We'll have. We do.
You do. Okay. Yeah. You should prepare some tissue because you cry, I'm sure. Yeah. So the big message from that is the genius, Alan Turing, a mathematician. He had a very wild dream that even before computers were created, he imagined that there will be a computer. And furthermore, by computation, the computer can possess intelligence. Okay, more than intelligence, emotion, sentiment, human characters. So he raised this issue, which is a question: can computers think? Can machines think? Okay, and as a result, he designed a game known as the imitation game, or aka Turing test. Okay. Now, since then, generations of people, young and old, devoted to artificial intelligence, and here are two of them. One is Herbert Simon, and another is Alan Newell. So two founding fathers of AI, and they participated the first conference in 1956. So at the meeting, they brought with them a computer program called Logic Theorist, which can prove many mathematical theorems that were even considered difficult for mathematicians. Okay. Now, there are many other achievements which I will not go through, but the point here is they did not use much data. Okay, almost everything they did that worked magically then were encoded by human rules or by so-called expert systems. So it can prove theorems, and that really raised eyebrows. As a result, there are some commercial exploit as well. There is the mathematical software package known as Mathematica. There's another package known as Maple from Waterloo. Okay, these are direct results of this endeavor. Okay, now, then in 1970s, people from MIT and elsewhere started thinking of different algorithms, and this is one of them, inspired by how human brain is constructed. Okay, roughly you have neurons, you have billions of neurons that are connected by even more connections. The number of neurons is in the order of 10 to the 11, okay, which is a very large number. but the number of connections is in the order of 10 to the 15th to 18th. Okay, and that's where the intelligence, the computation, and furthermore the learning happens. So on the right here, we have an artificial neural network. And in fact, it is an algorithm. Now, mathematically, if you study its behavior, it is trying to imitate a curve in a hyperspace, a function. Okay, it's trying to imitate a function. Based on what? Based on observation, based on data. So the data comes in from the left, and the output goes out from the right. So if you have some handwritten characters to feed it, eventually it learns the shape of these characters and can recognize new ones. So the keyword here is the generalization ability, and this is a hallmark of learning or machine learning. Okay, now in fact at this time it's still not clear which way intelligence will go, and many people are working on game. Okay, so meaning board game. So this is a tic-tac-toe people are familiar with, and you can organize it by a game tree. This is your move and this is your opponent's move. You take turns like that until you reach some point where you have enough knowledge. You can give evaluation to these leaf nodes, and then you back up. Okay. The big thing here is going down by search and going up by evaluation. Two things. So this brought about a IBM success in 1997, known as Deep Blue, right? Deep Blue computer, and Deep Blue in that event beat the world champion Kasparov. Okay. Now, so the main thing about this is exactly what we talked about, which is search in parallelism, in massive parallelism. Many possible directions are explored simultaneously. And evaluation. Evaluation here is by introduction of a new keyword known as crowdsourcing, okay, crowd intelligence. So imagine each of you is a chess player. I'm sure you are, but you may not be very good. Okay, but if you contribute your little bit of intelligence and your say, and we summarize them all somehow, and we can do it very quickly, then you get the effect of 1 + 1 greater than 2. Okay, this is the importance about crowd intelligence. So as a result, IBM brought together about 200 secondary champions where nobody cared, nobody knows, but they contributed evaluation functions. Collectively, they beat Kasparov. Now, with the progression of time, we are in 2011, and many people here probably have memories of this event when IBM Watson, IBM computer software known as Watson, beat the champion of Jeopardy game. Jeopardy game is different from the chess in the sense that it's an open world rather than a closed world where you have limited number of moves. The judge can ask any questions, and it's up to you to find the right answer and beat the others by in time and in correctness. So here, the lesson we learned is knowledge is power. And this is, in fact, something we learned from our childhood. Knowledge is power. But in fact, what's behind this is data. Okay, so the years and years of Jeopardy videotapes, plus Wikipedia, plus lots and lots of bulletin boards on the internet, collectively were processed by the computer. And a huge search space that cannot be possibly managed by 1 or 2 persons is searched very efficiently using the computer. So again, it's search, but it's not search in the space of chess. It's search in the space of data. Okay, so that's why this power comes from data, to be precise. At about the same time in 2010, people made a breakthrough in image understanding. So it used to be, if you are given an image, you take every pixel from the image, you feed it to the computer. In the case of neural network, you have many units that perceive this image and make transformation. But before this date, people use global connection. So in other words, every single pixel is fed to every single processor. Okay, and this made the computation impossibly slow. Okay, imagine everybody here has to read every book in the library. Everybody, literally. Then you can't imagine the date when you walk out of this library. Okay, so the revolution came when it is realized that, in fact, every processor only need to care about the region that's right next to it. It's like, everybody only read 5 books. Okay, and that's enough. By virtue of the algorithm, you don't lose that much information. So this is the idea of convolution in signal processing. And as a result, the network is called convolutional neural nets, or CNN. So CNN here is not the news broadcasting company. Okay, so what can it do? It can take a picture with many pixels and decompose it and go through layers of transformation by CNN and eventually grasp some important features. Okay, and it is based on these important features that we can make judgment. We can do computer vision, which is classifying images into categories, classifying sound waves into things we understand, and understand reading. Okay, and furthermore, in the most recent AlphaGo competition, it is found that CNN can understand the global trend of in which a game is going. So this is known as, in Chinese, it's called 大局观. Okay, so it's the global view. Only the masters can possess this. So many the non-dumb masters were totally surprised and thrown in disarray by the behavior. Now what next? People probably have heard of deep learning, but the next thing to come is known as reinforcement learning. Okay, you will see many examples. Probably the next big news item is on this. So the idea of this is very simple. Imagine yourself as a mouse, okay, traveling through a maze. You are trying to find your target. So how the mouse cannot have a global view, but it can do some recording. It has memory. It can sense different things, smell and shape. So it makes observations, but then every move it makes, it gets some feedback. And by virtue of this observation and feedback, it can make modifications to its model, which is the policy. And if you repeat this many, many times, the policy is going to approach the optimal policy. So this is true in many situations. The first observation of this algorithm came from zoology. So it was invented by a student in zoology, not computer science. Okay. Subsequently, people in economics make use of this because every government policy is like the mouse moving in a maze. You can use it in education. If I teach the student this versus that, what's the effect? And there are literally, so all the robot algorithms today use this. And this is also what AlphaGo used. And so by putting this together, deep learning and reinforcement learning, the Google team called DeepMind used a deep learning algorithm in the middle and connected what it sees to what it does, okay, in a computer game. So for those of you who are old enough to play the computer game, Atari game, you know that it's very addicting And some of them are very hard. So the question posed here is, with these two algorithms, can we ask the computer to learn without any human intervention, learn by itself, and learn from its mistake, and eventually get better than any possible human? And this is exactly what happened. Okay, so each of these is a game. So some of them are like the shooting the spaceship, ping pong, and so on. So with time, its competence grow with time. Okay, gradually, and eventually overpass the human performance. So this is a big thing. So now taking this one step further, we are in today, in last month, which is AlphaGo. It's the ability to search. Remember at the very beginning we had Deep Blue, ability to search in a giant tree, and the ability to learn. And these two are really, both are needed. Now what's behind this? In fact, now that brings us to today's topic. Now why did AlphaGo not happen 10 years ago? It's because both algorithms were available 30 years ago. Okay. Now it's because the data were not available. So there's a website known as KGS, which invites everybody in the world to compete in Go playing, and all the moves are recorded. Okay. You can also play with the automated agent there. But over time, they accumulated 160,000 games from which they extracted 30 million game board positions. And also, they let the AlphaGo to play by itself, and that generated a further 30 million game boards. And they use that for training. So this is what we mean by big data. Okay, it's humongous. But without the human patiently playing over the last 10, 15 years, we will not be able to get the data. So this teaches us one thing, which is if you want to make innovation, and this innovation relies on data, you have to live long enough. Okay. But data can be dangerous. And so this is an experiment done at Carnegie Mellon University, which runs a computer. We can call it Perpetual learning machine. It's really a perpetual machine in the sense that it extracts all the web pages one at a time and try to find some simple facts from this page. Okay, so one page may say Cameron is a professor. Another page may say HKUST is a university. And so it can put these two facts together and generate a third fact. So with time, the number of facts grow gradually. Okay, so you can imagine this is like a tirelessly learning kid. He's learning and learning, and as long as there are new web pages, it's going to learn. But at some point, it found that it can no longer learn because there are many facts that are self-contradictory. Okay, because some of the things this page said contradicts with some of the things that page said, or contradicts with the new knowledge generated thereby. So as a result, there's a drop in performance, and it has to be corrected manually by intervention by human, and then it continues. So this gives us the another lesson, which is if you rely on machine to accumulate data, the data can gradually become biased. Okay, so if you are have taken statistics course, then this image should be familiar. So if you want to build a model to recognize fruits, the best model here probably says everything is an apple. Okay, but here you are wrong. In the future, say in the application stage, your model can be wrong if all you encounter are oranges. Okay. Now, having said all that, let me tell you something that's going on in AI to further highlight the importance of data. So sometimes we are not so lucky, okay? We are not so lucky in the sense that we may not have these ready domains where data resides there and wait for us. Therefore, we have to be clever in the sense that we take the similarity between the domains and we revise, adapt a previously built model in one domain to fit another, even though the new domain may not have sufficient data. So you encounter this all the time. Okay, let's say if you are good at badminton, then perhaps you can find yourself learning ping pong a little easier than from scratch. And the reason for that is you took a large portion of previously built model in badminton to fit in the new domain of ping pong, table tennis. Okay, so this actually people have been using this for image understanding to counter the problem of lack of big data. So even when we have small data, as long as we can relate to a previously well-known domain, we can still work. Okay, so this is transfer learning. Now, so this is actually my field. So in my field, I take it to the extreme of having the source data completely different from the target data. So in other words, I ask the computer to read text, and then with that knowledge, recognize images. And it's fairly successful. So using this, we also generated computers that can automatically write poems from images or generate music from images. Okay, so all of these rely on portions of data, but what can the model tell us in addition to doing something boring like recognizing new images? In fact, when the model has learned many layers of features at different level of granularity, we can then ask the model questions. We can ask, what impresses you the most? Okay, so this is a model that recognizes maybe 10 million images. And then we say, what excites you the most? And they can output this. So this is known as a generative model. It outputs something like this. What does this remind you of? A dream, right? It's like computers can dream. So think of yourself. When you dream, you are outputting, you are seeing what impresses you the most. Okay? And so probably this is it. Try to watch a horror movie and then dream, okay? and you see what I mean. Okay. Another thing is you can ask model questions, some fairly sophisticated questions, such as what color are this person's eyes? What is the mustache made of? It can correctly say bananas. It can ask. You can ask the computer to count the number of pieces of pizza over there, and what objects are here, and their relations. And there are also works that allow you to use a single example. So this is another example of transfer learning. Once you transfer and have a very strong prior in statistics, you don't need that many examples anymore. Okay. Anyway, so here are a few more examples that I don't think I have time to go through. But so let me conclude that deep learning, the current stage of state of the art of AI, requires big data. So that's why some journalists ask me, where do you expect the next big breakthrough is? And my answer is simple. Look at where the next data is ready. Okay. However, so this is another point that I didn't cover. We need to recognize that deep learning requires humongous amount of data, but as human, we don't. So there is room for us to exist still. Okay, so that's good news. But we have to learn to work harmoniously with the machine. So in the future, we have new techniques, and especially pay attention to this reinforcement learning, which can give us the feedback loop. Thank you.
Thank you, Professor Yang. Very interesting talk. Does any of you have questions?
People are very shy today.
Yes, yes. Or maybe it's too high end.
Maybe, yeah. But feel free to ask me questions later on, because we are here at UST.
Yes.
Yeah.
May I ask a question?
Yeah, please.
It's a layman's question.
Okay.
2 months ago, USC set up the HKUST Big Data Institute,
Right.
and I also visited the Big Data webpage of your department. So can you tell us, what are the strategies of our university?
Right. Yeah. So as mentioned, we just created this Big Data Institute. The idea is to have a university-wide organization to help with both education and research. In education, we are going to launch a number of degree programs, such as we just got approved Big Data Technology master's degree and a Big Data Technology bachelor's minor. And then collaborating with social science, business, science, we are going to launch a few more masters, PhDs, so education programs. So that's number one. And this is in direct response to industry, society needs. The government, lots of industry require people with specific training in big data and data science. Second is we are hoping to set up several centers that are industry supported, such as the Center for Artificial Intelligence with WeChat. Okay, WeChat is this Chinese equivalent of WhatsApp plus Facebook plus Twitter plus anything else. Banks and hospitals and Uber. And as a result, it has tons of data and applications. So one of the things we are working on here is we consider the most advanced conversational robot that can allow a person to have a conversation with a computer and solve the person's problem as a result. The problem can be in any domain, such as education or hospital, medical, or in banking, you name it. Other objectives include understanding of how information travels in this humongous network composed of people. So for example, the daily active user of WeChat is 600 million. Thank you.
Thank you, Professor Yang. Okay, so we go to the next presentation then. Thank you. Becky from the library is going to give a brief presentation of issues surrounding data management.
Okay, very brief. Okay, I'm Becky from the library. We are so glad to have the above sharing section by Professor Campbell and Professor Yang. They are leaving. Okay. In addition, the library would like to introduce more important concepts about data management, and which you will find very useful. The first one is the funder requirements. Since research data is very valuable and important, it should be managed carefully and properly. So many funding agencies have the guidelines and policies for research data management during the proposal submission stage, it's very early stage. For example, this National Science Foundation, NSF in USA, on its webpage, it mentioned about the data management plan requirements. It states that proposals submitted to NSF must include a supplementary document of no more than 2 pages, labeled Data Management Plan, DMP. This supplementary document should describe how the proposal will conform to NSF policy on the dissemination and sharing of research results. Proposals that do not include a DMP will not be able to be submitted. So this is very serious. In UK, the MRC, Medical Research Council, has also this similar requirement during the submission, proposal submission stage. But in Hong Kong, the RGC, the Research Grant Council, have not yet implemented this kind of requirement. So some of you may say it's lucky, right? But in fact, we are lagging behind. Okay, what is data management plan? DMP is a document that describes what data will be collected or generated and how will be handled during and after the project. There are some common components in a DMP, including the type of data produced or collected, the access policy, the sharing policy, and the reuse policy. And also, as some of the participants mentioned, the confidentiality and also the intellectual property terms and conditions. Okay, but don't worry, there are some software tools ready for the researchers to compile a DMP. For example, the DMP tool produced by University of California and the DMP Online produced by UK Digital Curation Center. They all are free. After you complete your research, you're going to publish the articles or reports for showcase your results and findings. So not only the funding agency, but the major journal publisher also have the requirement to ask the authors to provide well-documented data used in the research and also make the data easily available to other researchers. For example, here are some major publishers' policy. Elsevier developed a platform called Research Data to support researchers to store, to share, to discover, and to use the data. Nature, they have the policy to ask the authors to make materials, data, code, and associated protocol promptly available to reader. Taylor and Francis, they provide a number of initiatives to ensure the supplemental materials is effectively included or linked to within the abstract. Okay. So besides you put your data at the publisher's site, you can consider, the researchers can consider to put the data on the open access data repositories. They are usually subject specific. For example, the social sciences. These two data repositories are very famous. The Harvard Dataverse is open to all scientific data for all disciplines. And the ICPSR is an international consortium for more than 700 academic institutions and research organizations. I know Professor Campbell has some data sets deposited in ICPSR. About other subjects like life sciences, they have gene bank and protein data bank. And for earth sciences, they have data one. Okay. Somebody's taking a photo. All right. Data citations. I think you all know well about the benefits of citing articles. Citing data brings the same benefits as citing articles because it can help data creators and users to find, access, verify, and reuse the data. It can allow the data impact to be tracked. And also it gives proper recognitions to the data producers. Here are some examples. This citation is simple. The citation mentioned about the name of creator and publication year, title, publisher, identifier. But we can have some more details like this. It mentioned creator, the name of creators, publication year, title, identifier, publisher, version, and also the UNF. universal numerical fingerprints. More details, and they are all unique identifier. Okay. There are two more elements that can increase the visibility of the data. The first one is DOIs. By adding the DOIs to your data set, it can make the data publication more acceptable for CVs, and it creates more recognition for data sharing. And also it provides a means of tracking publications. And other useful tools is the ORCID ID. ORCID ID is a unique researcher identifier for distinguish your publication from those of others with similar names. Maybe sometimes there are too many David Chen in social sciences, right? You can establish clear ownerships of your scholarly input. For the time being, we have 124 HKUST staff and 349 students already have registered their ORCID IDs. So you can use your HKUST login to easily create yours in a few clicks via this URL. So how many of them have not yet registered ORCID ID? All, so you all have? Okay, please try to go through this URL to get one. All right, so we bring a lot of information today about the data management. We put the details on this web page. Our web page is called Scholarly Communications at HKUST Library. The URL is here. When you go there and then you click on data management, the topics that we cover today will be shown the details through the hyperlink. For example, the funder requirements and publisher policies, the data management plan, the data repository, also the data citations. You can find more details here. All right? So if today you are feeling a bit overwhelming, don't worry. The library will not leave you alone. Library will provide services to support your research. So this one is a brief research data cycle. Okay, from the very beginning, data creation stage through managing data, and then the data repository and archives. The final will be data publishing. Okay. The library will provide services at different stages to support your work. For example, when you are starting your project, have the collecting data or planning the data, you can contact our subject librarians to have us consultation services, and we can help you compile DMP. Through when you are managing the data, doing collaborations, analysis, the data, we would provide you a workspace for that. And if your data is about to publish, you need a storage space to share, to manage, and to store. We will provide you a data storage space, data citation services, and also the metadata support services. Finally, if you are going to publish your data at our site, we can assign DOIs for your data set for you, and also connect with the data set with your ORCID ID if you have already registered. Okay. So most of these services can be provided by one single platform, our new services called Data Space at HKUST. We are going to talk about the function soon. Okay. Before go to data space, just let me want to tell you that you can contact our subject librarians through this URL. Okay, you are all welcome. So time for data space. We are glad to have Mr. K.T. Lam, our associate university librarian, and actually he is the chief designer of the data space functions to show the functions today. So please welcome K.T.
I can close all the windows because everyone is hungry, right? So this will be the last session. So I can just close everything. Okay, let me crop the PowerPoint. Is it? Before I go into the details, actually I cannot go into detail because it will take a long time. I'll just give you a very, very quick background on why we want to create this platform called Research Data Repository and Management Service. The library have done a survey for faculty last year to see how they perceive or think about the library's support on their research and so on. And one of the topic is on getting responses related to how they manage and preserve data and so on. And this is the highlight of what we got from them. 65% of the respondents said that during the cycle of the course of their research, they actually create collections of data. And most of this, what are those functions or features that they want to see in terms of data management? They want to have the ability to track how their research data are being cited, and how to manage the multi-version, how to store multi-version of their research data in the same place, and more, how they store the data together with the research output they publish and so on. And they perceive that the data support mainly come from free available software. I think all of you probably will have the same perception, right? That if there's something free that can help you in supporting your data, you use it right away, right? And interesting enough, they said university library probably is another source from where they can get support on managing the data. And actually, many of them were saying that they preserve or manage their data by themselves or by commercially available software. Okay? So this further confirmed our understanding that the library can actually provide quite important role in terms of helping researchers at HKUST to manage their research data. Okay? So just give this. Just recap what Becky has just said about the requirements from the publishers and the funding agents, right? Because the funding agents is giving you so many money, right? They want to make sure that the money they spend will have the biggest impact, right? So they want you to have the data broadly available for sharing, and also should be somewhere so that in long term people can still access to it, right? And the publisher obviously wants their readers to their journal to be able to replicate your research results that you published in their journal, right? So these are the back-end requirements. And where we can deposit data, Professor Cameron and also Becky mentioned some of these repositories, right? They are what we call, first of all, it's no good, right, to deposit your data in USB as an offline version, or even with your notebook computer. This is out right away. And Google Drive or Dropbox, is it a good place for you to preserve or put your data in it? I don't think so, right? Because it's probably not sustainable, or in long term is not good at all, right? So there are out there repositories that you can deposit data. The first one is domain specific, and you probably heard of all this, right? GenBank, right? Some mentioned about the Harvard Dataverse before, right? Becky mentioned that, and Professor Cameron has actually. Professor Campbell has actually some data sets deposited in this very specific political science, social science data sets and so on. So many of these required being a member, or sometimes requires some association with something, with the laboratories that for you to deposit data through it. More general repositories available in the internet. Drive is the one that usually allows you to archive your data which are associated with your published publications. This is mainly for the replication of your finding results. And FixShare is another one. It's another publicly accessible data repository that everyone can deposit with. Some are free, some are not free. And these are all choices that you can use. But there is the third group of repositories, which I think is for us is easier institutionally or project-based repositories, and Dataspace is one of them. Right? Okay, so let's get us into the demonstration. Dataspace actually has two functions. One is it acts as a repository, so that you can deposit your data set and make it openly accessible. More or less meaning that you are publishing your data set. Okay? And it also can act as a workspace, so that your research group, if you are a research group affiliated with your professor, your supervisor, then you probably have lots of data to handle, to manage together within the research group. So you can use this data space to manage your data, share or organize them. Okay? Dataspace was launched very quietly in February 2016. Currently, it has only 4 data sets. Okay, so now I'll click on this and see what sort of data set we have now. It's based on a software from Harvard University, and currently this software is being used in 14 installations. They're open source software. And the biggest one, obviously, is the Harvard Dataverse that Becky has mentioned previously. Okay, so these are 4 data sets. 2 of them are from the library. Want to test the water, see how it works. So the library deposit 2 data sets into it. One is on the Wi-Fi connection data in the library, and the other one is on the survey that I just mentioned, the response data I just mentioned. The other 2, the other 2 is the one that Professor Campbell deposited is on a household registers on a Korean county. Okay, so this is a small data set, but it's a complete one, and the other one is from a street air quality in the street. That this group of people, Professor Chen, Dunn, collected. They have a truck that go everywhere in the Hong Kong street and collect all this data, just like Google Maps approach. That was data collected in 2003, and we were able to have them give us the data and deposit into here. And here, once it's published, you see we provide them with a very good citation. Remember the data citation? This is a professionally created site, readily available citation. And in this citation, there's a link that Becky also mentioned. This is what we call BOI. It's just like a permanent address. Anyone that put this link anywhere, when you click on it, it will eventually get to this page. So it's just like an address, and it will be permanently preserved for long term. And then you have this metrics. Now this data set is being downloaded 43 times, and these are the tabs that you can go in and look at different things. For example, the files, all this data, right? Data files. There are 40 something of it, right? And you can download it. And once it's published, we want to make it openly accessible, right? So one of the requirements that you publish it is that you want to you have to put it as an open access. But of course you can restrict it for restricted access. This is also the software itself has this capability too. Metadata provides you very good quality information about the data set. This is very important information so that people, when using this data set, will be able to know what actually it is and so on, right? And the library will have a team to help you create this metadata. So anyone published on here will have this service provided. And the terms of use you can put all sort of license, user license on it, and version. It allows you to manage different versions of your data sets and so on. Okay. Let's get back quickly to the PowerPoint. The second function is workspace, right? So faculty and also the research group of their research group can create a workspace in database. So if you are postgraduate student associated with the research group, and the faculty can ask you to help them in managing the data set, so you can become part of the whole workspace process. So it's for store, manage, share data within the research group. And it is in a restricted environment, so only you, your own group, can have access to it. And to create a workspace is simple. You just click a link and submit it. Once you create the workspace, you can edit it, add data sets, upload files, and start sharing internally. And then if the data set is ready to publish, you just inform the library, and the library will have people to help you to publish it. So what it means for sharing internally, you will have a data storage that you can use for your whole research life cycle, and you can share this data with your collaborators right away internally under your permission. And if you are faculty, you can actually make the data set there as a class assignment or class project, and so on. And more importantly, it will help you in filling up the data management plan. You say that, oh, the data is well preserved or well managed in HKUST's data space platform. And the data is readily available when you publish, so that people can replicate your data. Okay. Let me quickly. Can I use 2 or 3 more minutes?
Sure.
Okay. And if you ask.
Let me make a reminder.
Okay.
Please remember to fill out the feedback form, and our colleagues are going to just fill some hands for you to fill out the form. Thank you.
Okay. So this is the URL for you to create the workspace. If you are a postgraduate student, make sure that you get approval from your supervisor before filling in the form. Okay. So you put in the project information and put in your members, collaborators that will become using this workspace. Okay. And it has very rich features for you to manage your data. Not going into detail, but from this slide you see it's really very lots of features in it. Particularly, you can determine who can access your data sets and so on. Okay. We have a data space team that help you through the process. Create the standard metadata, assign the DOI, help you in formatting the data, and also normalize the data files. If you have lots of data, just give us a USB or a hard disk. We can help you to deposit into the data space and so on and so forth. Okay, so this is the email address that you can send us if you need any help on it. And just as for your information, in fact, the library actually have more than just data space. A database is a new database that we just released, right? We actually have a few other services to support the research output, HKUST research output. If you are a postgraduate, you eventually will have a thesis ready, dissertation ready. So we have an electronic thesis database to keep which keep all the full text of all these theses. And database space we just mentioned. Scholarly publication database, actually we have a complete set of the research output all the publication, scholarly publication of the university. And if you have published the paper, it should be in there. It should be in there. Okay? And also it provides a profile for all our current faculty, so that to showcase their publications, showcase their bibliometrics and projects and so on. And all of this are under the same umbrella, what we call the institutional repository, IR. Okay, so everything, all this we just mentioned, can be found under institutional repository. Okay, so I think this is the last slide I have, and thank you. And see if you have any other questions to ask.
Thank you, Becky and Katie. Do you have any questions?